can we get humans on another planet? I mean, can we move the human race, or at least start another human race running on another planet? With the Kepler Space Telescope, we've learned about dozens or hundreds of Earth-like planets out there, and it's just tantalizing to think that maybe someday we will be on that planet. Well, you and I won't be, that's for sure. But this is a question that has interested me for a long time, and I've watched original Cosmos, that's the one with Carl Sagan, talk about these huge spaceships that could go between the stars. Interstellar space travel is possible, but is it economically feasible? It's unfortunate that these designs are so expensive that they probably will never happen. But I think it will still happen anyway. Not because it's big and expensive, but because today we can make things very small. This is what I think the spaceship will look like that will go from our planet to another planet. Very light, about this heavy, has a really nice telescope on one end, but more importantly, it's going to use a very interesting aspect of physics. You can take stuff and accelerate it really fast if it's small. So if you could accelerate something to 99.999 times this speed of light, its mass increases. And I think one really good way of getting there would be to take advantage of that. Have a particle accelerator in the middle of this that takes a very small amount of matter, maybe a gram, and accelerates it out the back end so fast that by the time it leaves, it's thousands of times its rest mass. And you'll get the oomph from that mass. So you don't have to carry a huge amount of mass with you. But you do have to you do have to have energy to accelerate these particles. So where could that energy come from? Well, you'd say, well, how about matter, antimatter? Well, that's kind of in the future. Maybe. Actually, if we get matter, antimatter engines, wonderful. I love it. Unfortunately, still a bit of science fiction. But one thing that's science sort of fact is these space sails. There's already experimental sails that will catch the solar wind as it comes out of the sun and, like a sail on a boat, blow it away from the sun. Now, unfortunately, the sun pressure is extremely minimal. It's tiny. So you would have to make this sail just molecularly thin. Imagine nanotubes, which is just a few carbon atoms over and over and over and again in a tube with some solar collecting material, some PV material, photovoltaic material that will catch the sun's light and turn it into electricity. So we lose a little bit of its mass because that one I showed you reflected, so you get twice the thermal mass of the mass of the photons, which I know they don't have any rest mass, push on this solar cell and push it forward. If you absorb those, it will go a little slower. However, you'll get a lot of electricity out of that. And that's what I want to run the engine off of. So the basic idea is that when this needs to accelerate away from Earth, and boy does it need to accelerate, I figure maybe 10 Gs. 10 Gs. That's a huge amount of acceleration for 3 days to get up to 0.1 C. So that's a very fast speed. Even still, it's going to take 40 or 50 years to get to this exoplanet. But within a lifetime, I figure we have to make the trip within a lifetime because very few people will want to launch something that they'll never get to see the fruits of their efforts. So I figure 10 Gs of acceleration would require quite a lot of electricity to run your little accelerator in here, throwing the particles out the back. And so there'd be a gigantic sail ahead of it that would pull this thing forward away from our sun and towards some other sun. Now, that solar wind will drop off by inverse square law as the ship starts to leave our solar system. By the time it's out by Neptune, the sun would be so dim. The sun's just another bright star in the sky. So I thought maybe a gigantic lens might help. So here's the sun. You see the beams are not parallel, sunlight coming out and hitting this gigantic lens, maybe a mile in diameter, and it would then cause the beam of light to be parallel so that it would stay the same amount of intensity for a long way before it hits the sail. That way, we could, here's a picture of our solar system. Here's the sun here, some junk, and then Jupiter, the only significant and Saturn, and then these outer planets are way out there. This beam would be continuously Well, until you get to here, it even break up at this point. But the point is we could keep a continuous acceleration this whole time at 10 Gs, so that we could get to 0.1 C before we leave our solar system. So imagine this thing buzzing along between our planet and the next one for 40 years. Well, it's got two problems now. One is it's got to communicate back to Earth. Well, it's got this big sail with it. Now that sail's going to have to be folded up because there is a little bit of stuff between the stars. It's not a perfect vacuum. And if we left this big parachute hanging out the back of this thing, it would slow us down. So it would pull it in and make it long and thin while we're traveling. And we could open it up when we start getting near the other star and actually use that drag to slow us down. Well, probably won't slow us down enough. But as we enter the other solar system, the light falling on that will generate energy. We can turn this around and use it to decelerate us on our way in around the sun, around the other sun, and then eventually, hopefully, drop into the orbit of the alien planet. At which point we can start using this really nice telescope to give high-res pictures of the surface of the planet and start beaming them back to Earth. Maybe 5 years later, those pictures will get back to Earth and we could start planning the next trip. Which would be an interesting trip, because I think the next trip, we probably would decide to drop something onto the planet. What? Microbes. Assuming there's no life on the planet, maybe there will be, in which case we'll pick another planet, let that one be, or we'll investigate that. But assuming we find a lifeless planet that's still in the Goldilocks zone, liquid water, everything's wonderful, it's about the size of Earth, rotates about once every 24 hours, kind of Earth-like. Kepler hasn't found one as good as I would like yet. We were going to have to keep looking. It's not really good at finding small planets. So let's say we find a planet that's about Earth size, rotates about Earth time, and it's about Earth temperatures, devoid of life. I think we could drop a little tiny pellet with thousands or millions of individuals in there, extremophiles, bacteria, algae, little one-celled plants that can handle really bizarre environments already on the Earth. And this, we've always said, the environment should be very much like Earth. Now, it's probably not going to have any oxygen in the atmosphere because that came from life. And as I said, we assume there's no life on this planet. So there's CO2, assumably. That CO2 can be converted into oxygen via these plants. It's got plenty of sunlight, so pretty much these little one-celled plants, that's all they really need, just CO2 and sunlight, and they can start multiplying like crazy. So we leave the planet for a while, just let it grow. One of those, we'll send millions of different individuals, but thousands of different species. Hopefully some of those species will do well and multiply like crazy. Now, this will take a long time, agreed, but, we got time. So then we send another ship. Now, this ship is going to send eggs, or one-celled animals. These one-celled animals will eat the one-celled plants that have now completely covered the planet, and they'll start growing. We'll have a little bit of oxygen by then, hopefully, in the atmosphere. Now, I know oxygen will tend to rust the iron that's around, and like this planet, I think, rusted for 1 billion years, but hopefully there's going to be so much of this green growy stuff on the planet that they'll produce enough oxygen for animal life. And those animals will hopefully grow and prosper, and we'll send more. And the whole idea of this is a tiny little piece of our ship will actually end up entering the planet, and being very, very small, it's not going to need much of a parachute. Or actually, if you just drop little pellets like salt, pellets the size of salt grains with their little animals and one-celled organisms that were all frozen as they came out from Earth, when they land, hopefully they'll take over and start to grow. Now, I know what you're thinking. You said humans, and all we are right now is we have eggs. Well, okay, we can obviously send bigger and bigger, or more and more eggs, but we can never really send anything of any real size because this whole idea is to keep this spaceship down to something you can hold. So I imagine that we will send eggs for larger animals, say reptiles, amphibians, and there's no problem with that because those eggs are very small. And so you can get those kind of animals, maybe even birds, on this planet, prospering, doing well. But we sort of want bigger animals. We'd like to have mammals. Well, we know mammals have to be born live. So how do you get a mammal onto the planet. You can't send a mammal. Even something the size of a mouse would be far too big. You can't freeze them. You can't keep them alive from here to there. How do you keep a mouse alive for 40 years, right? It's just impossible. You can't. The size of the ship would have to grow to ridiculous sizes. So how can we send a mouse without sending a mouse? Well, there is a point in which a mouse was very small, when it was a sperm and an egg, a fertilized egg. You can freeze a fertilized egg. So we can get the egg to the other planet, but there's no womb to put it in. Well, that's where we have to find one of these in-between animals, these animals with pouches that were born from eggs. And there's a couple of them on this planet, but I'm hoping that we might be able to breed something a little more useful in these hundreds of years that this will all take. Maybe genetic engineering. The hope is to breed an animal that would take maybe a silver, tiny little capsule and put it in its pouch. It just likes doing that. Just like a lab likes to catch a ball when you throw it, it's like, got to catch the ball. Well, if we could breed something with a pouch that's born from an egg that likes to put this shiny metal thing in its pouch, the pouch, when it heats up, could say, I'm in a pouch. I can eject that mouse egg, or that mouse fertilized egg, and it can grow in, well, it's not quite a womb, so maybe we can't go all the way to a mouse right away. Maybe we have to find some other animal that can grow in a pouch as opposed to a womb. Anyway, we finally get something that is born on the planet that needed to come from a womb, but actually came from a pouch. And of course, we'll do this several times, when they mate, they will have offspring who's born normally, and these animals can now take over. Well, these animals should also have sort of the desire to put small shiny things into their reproductive organs, such that we could send something that's more mammal-like or more human-like. So every animal we send should be sort of a little bigger and a little closer to humans, hopefully eventually getting to something the size of an ape, a chimpanzee, or a gorilla that, again, likes to find these things and use them. And we send human eggs that have been fertilized, that are frozen, in one of these little canisters, with the hope that one of these gorillas, who should be all around the planet, will put it in. The baby will grow up, and the human baby will be raised by a lesser form of animal life, a gorilla, chimpanzee. So the first humans on these planets won't know they're human. They won't be taught anything that the human race knows. We'll just be basically our flesh and blood. We'll have our intelligence, but we won't have our knowledge. Not yet, because once these beings start to multiply and do well, so there's enough of them, a couple thousand on the planet or something like that, we start to send cell phones or cell phone-like objects, a screen that can play videos. And the hope is these people will be naturally curious. If they find one of them, they'll pick it up, they'll poke at it, they'll talk to it, that will wake it up, and it will start playing videos of how to make fire, how to make a wheel, and slowly it will just keep teaching them everything we know today. Well, actually, probably you want to get them to a point where they can build a transmitter receiver, and that way we won't have to keep sending these cell phones. But anyway, the point is that we can educate them in situ. We don't send a person who already knows everything. We don't send an encyclopedia. We send very small objects over a long period of time, thousands of years. It will take thousands of years to get humans growing on another planet. But they should do what they did here. They should colonize the whole planet, take over everything, build up cities, and make another Earth. So that's my view of the future. I'd like to hear your comments and ideas. And if you think I said anything that was incorrect, please put a comment below. Thank you very much for watching.